This is the EdExcel GCSE 9-1 Maths paper 3, which is a calculator paper, and it's from the higher tier and it's from the Specimen papers set 1. Question number 1. The scatter diagram shows information about 10 students. For each student, it shows the number of hours spent revising and the mark the student achieved in the Spanish test, and that's what we see here. For part A, one of the points is an outlier, and we have to write down the coordinates of the outlier. Well, clearly, if we take a look at the points as shown here, this point does not follow the general trend and pattern of all these points here. So this point here is the outlier. So the coordinates of this point will be 4 across, 10 up. So the coordinates are 4, 10. For part B, for all other points, for the first part of part B, we have to draw the line of best fit. So if we go back to the graph, a line of best fit goes through as many points as possible. So we have something looking like this for our line of best fit. You can see goes through as many points as possible. We want roughly the same amount of points above the line as there are below the line. So therefore, this is the line of best fit. And now, for the next part, we have to describe the correlation. Well, if we take a look at the graph, you can see the more hours we spend revising, the higher the mark, and therefore as one variable increases, the other variable increases. We therefore have, of course, a positive correlation. Now for part C, a different student studies for 9 hours. We have to estimate the mark gained by this student. Well, if we go back to our graph, he spends 9 hours revising. So therefore, what we do is we draw a vertical line up from 9 hours. So if we just grab our ruler, we have, of course, here 9 hours goes up like this, and then we draw a line across from here. So if we do that, you can see we have 62 marks. So we have here 62 marks. And now for part D, the Spanish test was marked out of 100. Lucia says, I can see from the graph that had I revised for 18 hours, I would have got full marks. Comment on what Lucia says. Well, if we take a look at our graph, you can see 18 hours is outside of the data set, and therefore we can't make a good prediction about what she's saying because we'd have to extrapolate. So let's just write all of that down. So 18 hours is outside the data set, so therefore you'd have to extrapolate, and therefore the comment that she's said may be unreliable. Question number 2. The length L centimeters of a line measured as 13 centimeters, correct to the nearest centimeter, and we have to complete the following statement to show the range of possible values for L. Well, here we have an error interval, and therefore we'd have to find both the lower bound and the upper bound of L. So for the upper bound of L, that's equal to 13.5, and for the lower bound of L, this is equal to 12 0.5, and therefore, of course, to the nearest centimetre, L is equal to 13 centimetres. So therefore, for the error interval, we have 12.5, which is less than or equal to L, which is less than 13.5. Question number 3. Line L is drawn on the grid below, and you have to find the equation for the straight line L. Give your answer in the form y equals mx plus c. Well, of course, you can see here y would represent the gradient, so let's just write this down. So m would represent the gradient, so we can calculate the gradient by considering the change in y of the change in x. So for example, from here to here, we've got a change in y as 2, a change in x as 1, and therefore the gradient is equal to 2 over 1, which is 2. And for the c part, this would represent the y-intercept. The y-intercept, of course, is equal to 1. So the y-intercept is equal to 1, and therefore, the equation of the line L, we have y equals 2x plus 1. So we have y equals 2x plus 1. Question number 4. Jenny works in a shop that sells belts. The table shows information about the waist sizes of 50 customers who bought belts from the shop in May. So we've got small, medium, large and extra large, the waist in inches as an interval, and the frequency of those who bought the particular sizes of belts. And we have to calculate for part A an estimate for the mean waist size. Well, before we do anything else, I think it will be a good idea to work out both the midpoints and also the midpoint multiplied by the frequency. So let's just draw a line here. We have the midpoint. So for the midpoint, here we've got a midpoint of 30. Here we've got a midpoint of 34. Here we've got a midpoint of 38. And here we've got a midpoint of 42. We now need to work out the midpoint multiplied by the frequency. So let's just write this out neatly. We've got the midpoint multiplied by the frequency. So 30 times by 24, that's 720. 34 times 12, that's 408. 38 times 8, that's 304. 42 times 6, that's 252. So, we know already if we work out the mean, then the mean is equal to the sum of the midpoint multiplied by the frequencies over the sum of the frequencies. So here we have 720 plus 408 plus 304 plus 252 over sum of the frequencies, which is 24 plus 12 plus 8 plus 6. So let's work all of this out. On the top, 720 plus 408 plus 304 plus 252. On the bottom, 24 plus 12 plus 8 plus 6. it turns out we get 33.68. So we have 33.68 as the mean length of waist size. And let's write down the units, because here we've got inches. Okay, so let's just tidy all of this up. So here is how we work out the mean. So therefore we have 33.68 inches. Now for part B of the question, belts are made in sizes small, medium, large and extra large. Jenny needs to order more belts in June. The model size of belts sold is small, and that of course is confirmed by the frequency as shown here. Jenny is going to order 3/4 of the belts in size small. The manager of the shop tells Jenny she should not order so many small belts. Who is correct, Jenny or the manager? You must give a reason for your answer. Well, in total we have 50 customers, and of those 50, 24 have a small waist size. So let's find out the proportion of the belts sold which are small. So therefore, the proportion of small belts is equal to 24 over 50, which of course simplifies to approximately 1/2. And this is not equal to the 3/4 which Jenny is suggesting. Okay, so the 3/4 here corresponds to what Jenny is going to order. So therefore, you can see here that the manager is correct. So the manager is correct. Question number 5. The diagram shows a wall in the shape of a trapezium. That's what we see here. And Karen is going to cover this part of the wall with tiles. Each tile is rectangular, 15 centimeters by 7.5 centimeters. Tiles are sold in packs. There are 9 tiles in each pack. Karen divides the area of this wall by the area of a tile to work out an estimate for the number of tiles she needs to buy. For part A, we have to use Karen's method to work out the estimate for the number of packs of tiles she needs to buy. So here, first of all, you'll recognize that the dimensions of the wall are given in meters and the dimensions of the tiles are given in centimeters. So first of all, we need to make the units consistent. We can convert meters to centimeters to do that. To go from meters to centimeters, we need to multiply by 100. Centimeters to meters, we need to divide by 100. So, having said that, 0.8 multiplied by 100 is 80. So here we have 80 centimeters. 1.8 multiplied by 80 is 180. So here we've got 180 centimeters. 2.7 multiplied by 100, we've got 270 centimeters. So with this, what we can do is find out the area of the wall. And because we have a trapezium, that's quite easy to work out. So the area of the wall, that's equal to, if we work this out, 1/2 multiplied the sum of the two parallel sides, so we've got 180 plus 270. And then we multiply this by the height, which is 80. So if we work this out, we get 18,000 centimeters squared. We can now find out the area of the tile. which will help us work out the number of tiles needed. So to work out the area of the tile, we have 15 multiplied by 7.5, which is 112.5 centimeters squared. And therefore, the number of tiles needed will be 18,000 divided by 112.5. So if we work this out, 18,000 divided by 112.5, we get 160. So you can see that there's 160 tiles needed. And with this we can find out the number of packs needed. So we divide 160 by 9, which is 17.7, etc. So therefore, 160 divided by 9 equals 17.7, etc. So therefore, we can conclude that there's 18 packs needed. Okay, so therefore, we have 18 packs needed. And for part B, Karen is advised to buy 10% more tiles than she estimated, and buying 10% more tiles will affect the number of tiles Karen needs to buy. She assumes she will need to buy 10% more packs of tiles. Is Karen's assumption correct? Well, if we think about it, if we buy 10% more packs, 10% more packs means we need to multiply 18, which is the current number of packs she needs, by 1.1. So if we work this out, we get 19.8, which is approximately 20 packs. Okay? And if we work out 10% more tiles, then here we've got 160, which is the current amount of tiles she has. We worked that out before. And if we multiply this by 1.1, we get 176 tiles. Now, because we know that there's 9 packs in each tile, we can see if we divide 176 by 9, if we get something around 20, that means she's correct. So here, we've got 176 divided by 9. Well, indeed, if we work this out, 176 divided by 9, that's 19.5, etc. which is approximately 20. So therefore, if she buys 10% more tiles, she needs 20 packs. And we also found that because of this, she's saying she needs 10% more packs of tiles. And when we work out how many packs that is, that's 20 packs. And indeed, because of this consistency, we can conclude that she is correct. Question number 6, we have to factorize x squared plus 3x minus 4. Well, here we need to find two numbers which multiply to give minus 4 and which add to give 3. You'd find those two numbers to be 4 and minus 1. So therefore, when we come to factorize this, we have x plus 4 lots of x minus 1. Question number 7. Here are the equations of 4 straight lines. We've got line A, that's given by y equals 2x plus 4. Line B, that's 2y equals x plus 4. Line C, that's 2x plus 2y equals 4. And line D, that's 2x minus y equals 4. Two of these lines are parallel. Write down the two lines which are parallel. Well, first of all, if we rewrite everything in the form y equals mx plus c. This will help us find out the gradient, and of course m is the gradient. So if we take a look at line A, well, that's already in the form y equals mx plus c. So here the gradient is equal to 2. If we rearrange line B, we can divide by 2, so we have y equals 1/2 x plus 2. Here the gradient is 1/2. If we take a look at line C, first of all, subtracting 2 from both sides and then dividing by 2, you can see line C is equal to y equals minus x plus 2, so here the gradient is -1. And if we take a look at line D, rearranging, we've got y equals 2x plus 4. Here the gradient is 2. So therefore, the two lines which have the same gradient, of course, this is what we mean by parallel lines, the gradients. Well, here we're going to have the same gradient. Then here, you can see the ones with the same gradient is A and D. Question 8. Ian invested an amount of money at 3% per annum, compound interest. At the end of 2 years, the value of the investment was 2652.25, and for part A, we have to work out the amount of money invested. Well, here we've got the original amount of money, M. We will multiply this by 1.03, and then we will square this because we're investing for 2 years, and at the end of this 2 years he has 2652.25. Our goal is to work out what M is. So M is equal to 2652.25 divided by 1.03 squared. So if we work this out, we've got 2652.25 divided by 1.03 squared. It turns out here we get 2500. So we have 2500 for the original amount of money. Now for part B, Noah has an amount of money to invest for 5 years. So with savers account, that's 4% per annum compound interest, and with investment account, that's 21% interest paid at the end of 5 years. Noah wants to get the most interest as possible. Which account is best? You must show how you get your answer. So if we take a look at the saver account, here, the amount of interest will be 1.04 to the power of 5. So if we work this out, 1.04 to the power of 5, this is 1.216, etc. So therefore the interest paid at the end of 5 years, we've got 21.6, etc. %. And with the investment, we already know we have 21% at the end of 5 years. So which one gives more interest? Well, clearly you can see saver gives the most interest. Question number 9. The diagram shows two vertical posts, A, B and C, D, that's what we see here, on a horizontal ground. AB is equal to 1.7 meters, CD to AB is equal to 1.5 to 1. This is the ratio AC to AB. The angle of elevation of C from A is 52 degrees, and we have to calculate the length of BD. Give your answer correct to 3 significant figures. Well, what we have to calculate in this question is the length BD, so that's this one here. Now, we can use this ratio to find out the length of CD. CD is equal to 1.7 multiplied by 1.5. So if you work this out, 1.7 times 1.5, that's 2.55. So here we've got 2.55 meters. So let's add this to the diagram. Here we have, we work this out, here we have 2.55 centimeters, okay? And what we can also do is find out, well, let's take a look at this statement here. The angle of elevation from C from A is 52 degrees. So what this means here is if I somehow calculate, well, what we have over here is this angle being 52 degrees. Now, if I calculate this height over here, I can use trigonometry to find out this length here, which corresponds to BD. So this length here is equal to, if I work this out, (2.55) take away 1.7, which is 0.85. So here we've got 0.85, and our goal is to find out this length here. Okay, so if we use trigonometry, we have here the tan of 52 equaling the opposite, which is 0.85, over the adjacent, which is, of course, BD. And our job is to find out what BD is. So therefore, BD is equal to 0.85 over the tangent of 52. So let's work this out. 0.85 divided by the tangent of 52, that's 0.664, etc. So we've got 0.664, etc. meters, and therefore BD is, to 3 significant figures, 0.664. Okay, so here we've got 3 significant figures. Question number 10. On the grid, we have to shade the region that satisfies all these inequalities. We've got x plus y being less than 4, y being greater than x minus 1, and y being less than 3x. And we have to label the region R. Well, first of all, we need to make sure we use dotted lines because we have strong inequalities. And we can begin by drawing the lines as though we had an equal sign. So here we've got x plus y equaling 4. So if I draw that, you can see here we have something looking like this. Let's just show it in black, actually, a different color. So here we've got this line over here. Okay, so here is x plus y. Now we want this line to be less than 4, so we want everywhere underneath the line. Okay, and we've also got y being greater than x minus 1. Let's show this in blue. Well, let's just write down what this line is in red. We've got here x plus y being less than 4. Then we've also got y being greater than x minus 1. Well, for this we need to draw the line y equals x minus 1, gradient of 1, and it crosses through the point minus 1. So we have something which looks like this, okay? So here is the line y equals x minus 1, so we will be showing y being greater than x minus 1. And let's do the other one. We've got 3x, y being less than 3x, so here we've got a line which passes through the origin with gradient 3. So something which passes through the origin with gradient 3 is something looking like this. So let's just extend this as we see here, and let's extend it down to this point here, okay? So here we've got y being less than 3x, and we want the region satisfied by all of these points. So the region we want is everywhere over here, okay? And this satisfies all the points which we want, okay? So here is the region R, okay? Question 11, we have to write x squared plus 2x minus a in the form x plus ml squared plus n. Well, here clearly we have to complete the square. So when we come to complete the square, we need to first of all halve the coefficient of x. So here we've got x plus 1 all squared. Then we subtract off the square of 1. And then we still have the minus 8. So when we come to simplify, we have x plus 1 all squared minus 9. So we have x plus 1 all squared minus 9. Question 12. The diagram shows a cuboid A, B, C, D, E, F, G, H. That's what we see here. AB is equal to 7 centimeters. Let's just write all these lengths down. So here we've got 7 centimeters. Then we've got AF, which is 5 centimeters. And then we've got FC, which is this dotted line, which is 15 centimeters. And we have to calculate the volume. Well, for us to calculate the volume, we would of course need BC, and then it's a simple case of length times width times height. Now, for us to calculate BC, we first of all need AC. And we can do this by forming a right-angled triangle. So here, we have a right-angled triangle, something looking like this. We've got A, B, and C. We've got 15 centimeters as given here. Then we've got 5 centimeters as given here. So now we need to calculate AC. So AC, we'll do this in red, is equal to, through Pythagoras, 15 squared take away 5 squared, so this is AC squared. So if we work this out, 15 squared take away 5 squared, this is 200, and therefore AC is the square root of 200, which is 10 root 2. So therefore AC is equal to 10 root 2. So we have 10 root 2 centimeters for AC. Okay? So therefore, this length here, which we'll show in a dotted line, is 10 root 2 centimeters. And we need to calculate BC. So if I draw out another right-angled triangle, okay, so let's just copy and paste this actually, but just change the numbers and the letters. So if I just scribble these out, we've got here B in the corner here, A and C, and we know AC is 10 root 2 centimeters. So here we've got 10 root 2 centimeters. We've got AB, which is 7 centimeters. That's given in the question, and we need to calculate BC. So here we can use Pythagoras again. So here we've got BC squared equals 10 root 2 squared minus 7 squared. So if we work this out, we've got 200 take away 49, which is 151. So therefore BC is equal to square root 151. So here we've got 151 centimeters. So here we've got 151 centimeters. So therefore, for us to calculate the volume, well, the volume will therefore equal the base times by the height. Rather, here we've got square root 151. So here we've got square root 151 multiplied by the 7 multiplied by the 5. So if we work this out, we've got square root 151 times 7 times 5, which is 430.08, etc. So we've got 430.08, etc. centimeters cubed. So therefore, to three significant figures, we have 430 centimeters squared. Question 13. There are 14 boys and 12 girls in a class. We have to work out the total number of ways that one boy and one girl can be chosen from the class. Well, here we have to use the product rule for counting. So we've got 14 boys, 12 girls, and if we multiply those together, we get 168. So there's 168 total ways in which we can have one boy and one girl being chosen from the class. Question 14, we have to write 4 minus and then in big square brackets x plus 3 divided by x squared plus 5x plus 6 over x minus 2. Well, here, if we concentrate on the x squared plus 5x plus 6, we need two numbers which multiply to give 6, which add to give 5. You'd find those two numbers to be 2 and 3, and therefore we can conclude that x squared plus 5x plus 6 is equivalent to x plus 2 lots of x plus 3. Now, having said that, let's tidy all of this up. Here we have 4 minus, and then in square brackets, x plus 3 divided by, and then if we draw a line here, we've got x squared plus 5x plus 6, and on the bottom we've got, well, here we've just said this is equivalent to x plus 2 lots of x plus 3, and then on the bottom we've got x minus 2. So our job is to tidy all of this up, okay? So we have here 4 minus, now again we've got the square brackets, we've got here x plus 3, which I'm going to rewrite as x plus 3 over x over 1, and then we're going to multiply. Now here, of course, when we divide fractions, we keep the first fraction, we change the divide to a times, and then we flip the second fraction. So here we've got x plus 2 lots of x plus 3. And on the top we've got x minus 2. Okay, so this is what we've got here. And what you'd find is the x plus 3's cancel. So here we have 4 minus x minus 2 over x plus 2. And now we need to write this as a single fraction. So we can do this by rewriting the 4 so it has a denominator of x plus 2. And for us to have an x plus 2 on the bottom, we need an x plus 2 on the top. It's as though the x plus 2 on the top and bottom cancel out to give the 4. And then of course we're going to subtract off x minus 2 lots of x plus 2. Now because we have a common denominator here, we can combine the fractions. So we've got 4 lots of x plus 2 minus, now here be careful, we've got minus x minus 2. And then here on the bottom we've got x plus 2. So if I expand and simplify, we've got 4x plus 8 minus x plus 2, and on the bottom we've got x plus 2. So now if I tidy up this even more, 4x minus x, that's 3x, 8 plus 2, that's 10. So we've got 3x plus 10 on the top and x plus 2 on the bottom. So this is our final answer. So we've got 3x plus 10 over x plus 2. Question 15. A virus on a computer is causing errors. An antivirus program is to remove these errors. An estimate for the number of errors at the end of t hours is 10 to the 6 times 2 to the minus t. We have to work out an estimate for the number of errors on the computer at the end of 8 hours. So here, when t equals 8, the errors is equal to 10 to the power of 6 multiplied by 2 to the minus 8. So if we work this out, we've got 10 to the power of 6 multiplied by 2 to the minus 8, which is 39 or 6.25. So therefore an estimate for the number of errors will be 39 or 6. Okay? And now for part B, we have to explain whether the number of errors on this computer will ever reach 0. Well, if we think about 2 to the minus t, well, 2 to the minus t is the same as 1 over 2 to the power of t. And if we graph that, something like this, where we have here the errors and t, then we've got something looking like this. Okay, so this is the graph of 10 to the 6 times by 2 to the minus t. And this will never approach 0. So therefore, we'll never have a computer with 0 errors, so therefore we have no, and that's because 2 to the minus t can never be 0. Question 16. The graph of y equals f of x is transformed to give the graph of y equals minus f of x plus 3. The point A on the graph of y equals f of x is mapped to the point P on the graph of y equals minus f of x plus 3. And we have to find the coordinates of the point A are 9, 1. We have to find the coordinates of P. Well, here you can see to go from y equals f of x to y equals minus f of x plus 3. What we have over here is a reflection in the x-axis followed by a translation by a vector minus 3, 0. So what we need to do, if we think about the coordinates of, well, if we're reflecting the x-axis, that means we multiply the y-coordinate by minus 1. 1 times minus 1 is minus 1. And then for the x-coordinate, we need to subtract 3. 9 take away 3, that's 6. So the new coordinates of P will be 6 minus 1. Question number 17. The diagram shows a solid cone, that's what we see here. And the diameter of the base of the cone is 24x. That's what we see here. The height of the cone is 16x. The curved surface area of the cone is 2160 pi. The volume of the cone is v pi centimeters cubed, where v is an integer. We have to find the value of v. Well, for us to find out what v is, well, we need to find out what x is, and we also need the radius. Now currently we can find out the radius in terms of x. The radius is half the diameter, half of the 24x, that will be 12x. So we've got 12x for the radius of the circle at the bottom here. Now we know what the curved surface area is. That's 2160 pi, and we know what that is with this formula. That's pi RL. And we know the radius is 12x, but we don't know what L is, the slanted height over here. But we can find that out using Pythagoras. So if I draw a right-angled triangle, we have over here 12x for the radius. We're finding out what L is, and we know the height is 16x. So L squared, that's equal to 12x all squared plus 16x all squared. So if we work this out, we have 12 squared plus 16 squared, which is 400. So here we're going to have 400x squared, and if we square root that, you can find L to be 20x, which is the square root of 400x squared. So here, the slanted height, as we see here, is 20x. So with this, we can equate this equation, the pi RL. So here we've got pi, R, which is 12, L, which is 20x. This is equal to 2160 pi. Now the pi's cancel on both sides, and 12 times by 20, that's 240. So we've got 240 x squared equals 2160. And if we divide through by 240, 2160 divided by 240, that's 9. So x squared equals 9, and therefore x is equal to 6. Rather, x is equal to 3. So we can find out the radius. You'd find the radius over here to equal 12 times by 3, which is 36, and the height, that's equal to 16 times 3, which is 48. So now we can find the volume using this formula here. So therefore, the volume is equal to 1/3 pi r squared. So here we have 36 squared multiplied by h, which is 48. So if I work out the volume is equal to 36 squared divided by times by 48, and then divide this by 3. Let's start 36 squared times 48, divide this by 3. We end up with, over here, 20736 pi. Okay, so the value of V is 20736. We don't need to include the pi because we have here V pi centimeters cubed, and V is the number in front of the pi. Okay. Question 18. Thelma spins a biased coin twice. The probability that it will come down heads both times is 0.09. We have to calculate the probability that it will come down tails both times. So first of all, probability of a head followed by another head, that's equal to 0.09. So therefore, this implies that probability of head times probability of head equals 0.09, and therefore probability of head is equal to the square root of 0.09, which is 0.3. So therefore probability of head is 0.3, so therefore probability of tail is equal to 1 minus probability of head, which is 1 minus 0.3, which is 0.7. We're finding out probability of getting tail twice, so probability of tail followed by another tail, we have 0.3 times 0.3, rather here we've got 0.7 times 0.7, which is 0.49. So we've got 0.49. Okay. Question number 19. For part A, we have to write 0.000423 in standard form. Well, here we need to move, well, what is standard form? Standard form is when a number is of the form a times by 10 to the power of n, where a is in between 1 and 10. So we need to move the decimal place so that a is in between 1.1 and 10. So here we've got 1, 2, 3, 4 places to the right. So we've got 0.00, rather here we've got 4.23 times 10 to the minus 4. And now for part B, we have to write 4.5 times 10 to the 4 as an ordinary number. So here we've got 4.5, and we will move this decimal place 1, 2, 3, 4 places to the right, and we fill the rest of these with a 0. So here we've got 45000. So this is the answer as an ordinary number. Question 20. Mark has made a clay model. He will now make a clay statue that is mathematically similar to the clay model. The model has a base area of 6 cm squared. The statue will have a base area of 253.5 cm squared. Mark used 2 kilograms of clay to make the model. Clay is sold in 10 kilogram bags. Mark has to buy all the clay he needs to make the statue. How many bags of clay will Mark need to buy? Well, here we've got the statue. We'll show the statue here. So this is the, well, what we'll do actually, if I copy and paste this, here is a big model and here is a little model. So here for the little model, we have the, well, we've got the model here, and here we've got the statue. Okay. Now, this has a base area of 6 centimeters squared. This has a base area of 253.5 centimeters squared. Let's just move this over here. So with this, we can find the area scale factor. So area scale factor, that's equal to 253.5 divided by 6, which is 42.25. So therefore the length scale factor, that's equal to the square root of this, which is 6.5. So therefore the volume scale factor, that's equal to 6.5 cubed. So if I work this out, we get 274.625. So we have 274.625. So how does this help us? Well, for the statue, we can find out how much clay he needs. So of course, to go from here to here, we need to multiply by 274.625, and here to here, we've got to divide by 274.625. So therefore, we can see here for the statue, we need 2, because we've got 2 kilograms, multiplied by 274.625, which is 549.25 kilograms. So therefore, we also that well, we know that clay is sold in 10 kilogram bags. So therefore, the number of bags we need is 549.25 divided by 10, which is 54.925, which we can round up to 55. So therefore, we need 55 bags. Question 21. For part A, we have to show that the equation 3x squared minus x cubed plus 3 equals 0 can be rearranged to give x equals 3 plus 3 over x squared. Well, here we will begin with the 3x squared minus x cubed plus 3 equals 0. If we rearrange, we have x cubed equals 3x squared plus 3, and if we divide through by x squared, you'd find x to equal 3 plus 3 over x squared. So that's what we wanted to show. And now for part B, using xn plus 1 equals 3 plus 3 over xn squared, with x not equaling 3.2, we have to find the values of x1, x2 and x3. So x0, that's given by 3.2, x1, that will equal 3 plus 3 over x0 squared. So we've got 3 plus 3 over 3.2 squared, which you'd find, well, here what we can do actually, if we type in 3.2 into the calculator and press answer, 3.2 is now stored into the answer key. So here if we type in 3 plus 3 over answer squared, here we will end up with 3.2929687.5. Press equals again. This is the value of x2. So x2 is equal to 3 plus 3 over x1 squared. So we've got 3 plus 3 over 3.292 etc. squared, which is 3.276659,786. And x3 is equal to 3 plus 3 over x2 squared. So we've got 3 plus 3 over 3.27 etc. squared. So working this out, we end up with 3.279420,685. So this is the value of x1, x2 and x3. And for part C, we have to explain what the values of x1, x2 and x3 represent. Well, here they would represent the estimates to the solutions to the original equation. Question 22, here are the first 5 terms of an arithmetic sequence. So we've got 7, 13, 19, 25 and 31. And we have to prove that the difference between the squares of any two terms of the sequence is always a multiple of 24. So here we need to subtract, we need to find the difference between each of these terms to find the nth term of this sequence. So here, difference here is 6, 6, 6 and 6. So if I find out the 0th term, I would have to subtract 6, 7 take away 6, that's 1. So therefore, the nth term here is 6n plus 1. Now we need to find the difference between the squares of any two terms of the sequence. And we want to show that this is a multiple of 24. So what this means over here is p squared minus q squared is equal to 24m. So what does this mean? Well, here we've got the difference of any two terms. So any two terms refers to p. We've got the square of this over here and over here, and we want to show that the difference between these is a multiple of 24. This is what we want to show. So what we will do is we will let p equal 6x plus 1 and q equals 6y plus 1, okay? For different integers x and y. So x and y belong to a set of integers, okay? So they're positive integers here actually. So let's find out the difference. So we've got 6x plus 1 all squared minus 6y plus 1 all squared. So if we work this out, here we will end up with 36x squared plus 12x plus 1 minus 36y squared minus 12y minus 1. Well, here the plus 1 and the minus 1 rather here we've got plus, got a plus here. Just undo all this. So here, this is a plus rather. So here, if I expand this minus into the bracket, we've got 36x squared plus 12x plus 1 minus 36y squared minus 12y minus 1. So this and this cancel. So we are left with 36x squared minus 36y squared plus 12x minus 12y. And we can take out a 12 as a common factor, so we've got 12 lots of 3x squared minus 3y squared plus x minus y. So how does this help us? Well, as x and y belong to a set of integers, I'll just leave it as just integers for now, it follows that 3x squared minus 3y squared plus x minus y also belongs to a set of integers. And 12 is a factor of 24, so 12 is a factor of 24. So therefore, what we can conclude is 12 lots of some integer is always a multiple of 24. So that's how we approach this question.